I don't want to delay this any longer, so let's get this kicked off. Awesome. So yeah, excited to have Yusef here from Protocol Labs side. He's going to walk us through a nice talk about kind of minting NFTs and putting them on IPFS and kind of doing all the cool stuff. So it's really important, as we think about NFTs, that we keep things as decentralized as possible. IPFS provides an awesome layer for that. And of course, as you think about getting started building with NFTs, I think Yusuf's going to be your guy to give you all the info you need. So I'll hand it over to Yusef. If you have any questions or anything, feel free, of course, to drop them in the chat here. We'll save some time at the end so that we can answer those questions as we go along. And yeah, otherwise, hope everybody enjoys the chat, and I'll turn it over to you, Yusef.
Thanks very much. It's great to be here. And let me just go ahead and share my screen and find my slides, which are around here somewhere, I expect. There we go. Right, so we're talking about minting NFTs with IPFS and Friends, which is something we've been thinking about a lot lately at Protocol Labs. NFTs, for you've never heard of them before, it's a thing on a blockchain, basically. It's an NFT is basically like a record that lives on some blockchain machinery somewhere, and it can be owned and bought and sold. So some key properties of an NFT, right? It has a unique identity inside of a smart contract or a similar record that's being maintained on a decentralized blockchain network. It can be owned, transferred to a new owner. This is not necessarily like an intrinsic property, but it's true of most systems today, where it's that a NFT can generally only store a very small amount of data directly inside the record, because blockchain data storage and smart contract systems tends to be quite expensive because you need global consistency. Everybody has to come to agreement on the state of the world, and that costs a lot when you start talking about lots of data. But then to work around that limitation, you have links, right? So most NFTs in the world today are essentially like fancy hyperlinks. They have a reference to some asset and metadata that lives off-chain, right? So outside of the blockchain network, usually just using a URI. So that's there's an interface for NFTs. There's several now because there are many blockchains and smart contract platforms. Well, I often will speak about Ethereum as if it's the only blockchain, but that's just because I had been working with it most recently. But and of course, it was sort of the initial proving ground for NFTs, where the whole idea kind of emerged. But there are other blockchains, of course, and they have unique properties that get well into the weeds about at some point. But for now, I want to sort of drive home this message, which is that HTTP, like the traditional hypertext transfer protocol that we use for regular web browsing stuff, is not a good fit for linking from an NFT record to something in the external world, because they're great, they're familiar, they work everywhere. So that's a huge advantage, but they're fragile. They are inherently location based, right? So when you have a web link, it's going to have a domain name or an IP address maybe, but either way, that points to a specific machine, and then that points to it. Then you'll have a file that points to like a particular location on that machine, or the server can do whatever they want with that. But there's no guarantees about what's going to come back when you hit that URL. It's just not the way the web works. Like, you can hit a URL today and get something completely different tomorrow. And somebody may have bought the domain, or the website owner decided to change it for whatever reason. And so that kind of breaks the fundamental premise of the NFT as a durable record of information and storage. Because like, if you think about what you're actually purchasing, right? Like if you buy an NFT, that durable information that's written in the blockchain will never change. But if it's just a fail link, then that doesn't really help you out very much. But we think we have a solution for this in IPFS, which is something, IPFS has been around for a long time, and it sort of the NFT use case just sort of fell into place with it. So it's a really good fit. The way IPFS works, right? First of all, you add your data to it and to IPFS on your local machine, And it gets chunked up into pieces, and we generate this thing called a content ID, which is a cryptographic hash of all the data that you have. So this one little string, it's like maybe 40 odd characters of random gibberish. That string can be used to locate and fetch the data from anybody else who has a copy of it. And when you get the data back, you can compare it to the original string and validate it, checks. So that means that you can sort of trust but verify in a way that, like, if somebody is sending me data in response to my request here, then I can say, okay, I know for a fact that it's going to be the exact same data that I handed over to them. And I don't have to care who gives me the data because I can always validate that it's correct, right? So IPFS uses this to build this big peer-to-peer information sharing network, right? So we have nodes all over the globe and people add their data to IPFS. I can give my IPFS content identifier, the CID, to anyone, and they can fetch it, and whatever is the closest node will respond the quickest, and I'll get it from them. And if they only have a piece of it, I can get the other piece from somebody else. So it's cool, and it's it works. It's been around for a while, but there are, and the reason it is a good fit for NFTs, I should say, is that we have that string, that content identifier never changes, right? It's always tied to that one piece of content. So there's no danger that like somebody else is going to buy out a domain name or anything like that. It's just, as long as IPFS exists, that link will be valid. But that there are, if everybody gets rid of it, so there's some caveats. The first is that if nobody is storing it anymore, like all the people that the IPFS nodes forget about the content, then it's not retrievable anymore. Although if somebody then later came and added it again, you could still use the original link. So it is still possible in the IPFS world for data to kind of disappear, just if nobody has it online at that moment in time. And the other caveat is that can happen periodically if, like when you add your data, so you add your data to IPFS, it kind of spreads through the network naturally, and people keep a copy locally, and that kind of helps propagate it and helps like share the load of retrieving that data. But all those copies are kind of temporary, and they'll get garbage collected. So that means that we don't want to fill up everybody's disk, indefinitely. So we'll run periodically a little cleaning algorithm to say, oh, well, you haven't told us this data is important, so we'll just flush it aside. So you can't really rely on like the generosity of the IPFS network to store your stuff, but you can sort of contract that out to people and say like, hey, would you please, we call it pinning, will you please remember this piece of data and keep it online for me? So you can either do that on your own IPFS machines, or you can do it through a service. Like there's an ecosystem of pinning services that will do this for you, and they run IPFS nodes and keep your content online. But we at Protocol Labs, when we saw NFTs kind of taking off into the public consciousness in February, March of this year, we were like, hey, well, this is amazing. Like, we should make it super easy for people to use IPFS and use it in a way that we think is sort of future-proof. Because the downside of it's downside, but like one thing to keep in mind when you're building for blockchains is that when you write data, it's forever. Like, you can't easily change it after the fact. So it's nice to, if you can sort of make sure that everything is all in a good format for the future. And we think IPFS has some things to say there and to help. So we built this thing called NFT.storage, and it's one of the easiest ways to get data into IPFS or to use IPFS without having to install anything, because we're running as hosted service. It's sort of like an onboarding point into IPFS, and then from this IPFS layer where everything is sort of easily retrievable by this decentralized network, we're also persisting all of the data that is stored through NFT.storage to Filecoin, which is our other crazy decentralized storage project, which is in fact itself a blockchain network. Although unlike Ethereum, it doesn't currently support arbitrary smart contracts, but what it does support is large volumes of data storage. So the way Filecoin works basically is you have all these storage providers that basically run data centers and rent out storage capacity, and they'll prove that storage. Like when you can contract out to like, hey, I've got a big chunk of data, give it to these storage providers, and so this is sort of the NFT storage flow kind of. But sorry, backing up a second. Without NFT storage in the mix, you can store data directly on Filecoin in this decentralized way. NFT storage kind of eases the path for you by aggregating lots of small pieces of data and making like really attractive deals to the storage providers to say, hey, like this data is in the format that you like it, and all this stuff. And so we're like taking on the overhead of managing these Filecoin deals and all this. And we're also providing it as a free service because we want people to use it as much like NFT data that is backed up by Filecoin and on IPFS as we can get, because we think that this is a great use case for IPFS. And also we think this will help bootstrap Filecoin and kind of really be a good public resource, because as more and more digital culture gets kind of like encoded in NFT form, I think that you're going to start to see, unless we're careful, we'll see a lot of those NFTs just kind of disappear, as we've seen on the web, where you just can't trust links to stay around. Like if anybody, I don't know, I grew up on the web where I had a big, well-organized bookmarks folder, and when you come back, maybe even like a year later, at least like 40% of those links are gone. And now the only work around that by keeping local copies of everything that I really need to remember. So Filecoin is kind of like, and the whole blockchain ecosystem in general is trying to build this alternative path where we can have these really durable digital artifacts. And we think that NFT storage is kind of like the first, or one of the first steps to bridge the gap between the web we have today, where it's really easy to use. So NFT storage is trying to be easy to use in that sense of like, we have a very simple JavaScript API. It's HTTP, so you can talk to it from a browser or from whatever language you want. And then from that sort of entry point, it goes out onto this decentralized storage network, where then other decentralized systems can interact with this public data and using this content identifiers and stuff. So we think it's really cool, and will hopefully broaden the accessibility of this whole ecosystem, which can be a little intimidating especially when you're first getting used to it, all these new concepts. So if you go to NFT.storage, it's free. Sign up for an account through email or GitHub, and then we have this JavaScript client that makes building stuff really easy. And one of the nice features too is that like we're a little opinionated in this store method, which I think is the recommended method here, about the shape of your metadata, because we think that's one of those things where like you want to be compatible with everybody, so it's good to kind of adhere to a standard if you can. And so we kind of try to guide you in that direction here. So if you use the API as it's written out here, it just does the right thing for you and formats everything with IPFS links the way that in a way that plays nice with the ecosystem. So we have a bunch of clients in different languages, and these all talk to the HTTP API. I'm jumping ahead a little bit. So along with NFT.storage, we've been building this thing called NFT School, and it's still pretty early here. You can see, well, this screenshot is a few weeks old, so we've chipped away at a couple of these little under construction signs, but we are still building it. So it's, you can see the ambition on the walls, as it were. But I personally would appreciate it if anybody wants to go check it out, because I've been building some of these example apps and writing tutorials and things, and it's been fun working on it, but I need input or what's the most important thing to do next. So you can help me out there. In a minute, I'll show one of the example apps, and we can sort of get into the weeds about how NFTs actually work under the hood. So yeah, let's do it. I guess I'll do this real quick. And then after that, we'll have some quiet Q&A, and we can just talk about NFTs and IPFS and Filecoin and all that. So let me switch over here, and no, not there. Yeah, I think I need to, there we go. So yeah, for a demo of how this all fits together, using NFT storage and kind of using IPFS, I figured it might be nice to talk through one of those NFT school examples that I wrote, because it's a pretty decent, sort of intro to how this can work. There's a lot of ways to kind of do this. I mean, there's a bunch, like I was alluding to earlier, there's stuff at different blockchains, and there's lots of, for each blockchain, there tend to be lots of different tools and stuff. So NFT School is kind of our attempt to lay out, some opinions about here's a sensible way you can do it. And then also, we want this to be a community endeavor. So we're soliciting, if you guys have opinions about how it can be done, please tell us. But for now, I'm going to tab over to this terminal, and we'll start it up and see what's going on. So we have this repo that you can check out from GitHub. And I'm going to run a little mini development blockchain in this project. This is a Ethereum in a box. Basically, it's just running on my laptop. And now I'm going to deploy a copy of this smart contract. I'll show you the code for that. So see, there's nothing up my sleeve. It's a very simple contract where you call it a mint token function, and that increments a little counter to become the token ID. And then you give this metadata URI, which is how you link out to the real asset. So the way that NFTs tend to work is you'll link directly from the blockchain to a metadata manifest, which is almost always a JSON object. And then from there to whatever other media, like images and videos and things that you might have. So that's how this is structured. It's using the sort of original ERC 721 standard, which is the first formal NFT standard to be adopted by the Ethereum community. So yeah, there's nothing fancy here, and it's not production ready or anything like that, but it's just there to demonstrate how the process works. And so then if we go back over here, we can start our little front end, and that'll kick us off to a little React app, which is not the prettiest app in the world, but it has some interesting functionality if you click through, because it's based on a very cool starter project called Scaffold ETH, which comes with lots of batteries included for Ethereum development. So we can get some fake money to play with here. It gives us a little bit of pretend ether. And then we pick something to mint. So what this is going to do is upload this image and some metadata to NFT.storage. NFT.storage is going to make it available on IPFS and Filecoin. And then the service is going to give me back the IPFS CID for this whole NFT bundle. And then the code here, which tab to in a second, is going to take that CID. I'll talk through the code. So hopefully you guys can see this, and it's not too tiny. But so we're making an NFT storage client. We are going to call that store method with our metadata here, and then it's going to give us a CID and a metadata URI that we stuff into our smart contract. And then that's basically it, that we call the mint token function contract. And then we have to wait for the transaction to be confirmed, and we get the token ID out of the little transaction receipt. So that's, if you want that, click through this yourself, there's links to the code and explanations and stuff on that nftschool.dev article. So then back over here, we can, on this little site, we can say, okay, show me the token, and it will go and fetch it again from IPFS. So this time it took a second because I had to go fetch it from IPFS just from my laptop. So that's kind of a quick example of how you can mint an NFT easily with NFT.storage. If you want to do the sort of, I don't want to trust NFT.storage, I want to do everything myself route, you could check out on the IPFS doc site, there's a guide to minting NFTs with IPFS where you use a local IPFS node. And it talks about the things you would want to do if you were going to set up your own infrastructure or use a remote pinning service or something like that for persistence. But we are, like I said, we're really excited about NFT.storage. And I think, if you guys want to join the party there, that would be great. The more NFTs we're storing, the happier we are. So, and I guess open it up to some Q&A. Share the screen here. So we've got some stuff in the chat here. So yeah, about the pricing, it is totally free. We are subsidizing. Well, it's an interesting relationship because we have this ecosystem of Filecoin storage providers, right? Who are incentivized to they actually get economically rewarded through the protocol for storing useful data. So that's kind of an interesting economic equilibrium there that I honestly I'm not the guy to talk to about that, but that's one piece of the puzzle. But then the other thing is we really want to bootstrap the ecosystem. Excuse me, sorry. One second. Sorry about the dog. So yeah, it is totally free. It's going to be free for as long as we run it, which we hope to be forever, basically. But in the terms of service, we're saying that if we ever have to shut it down, we'll give you 90 days notice by email so that you can find an alternate persistence mechanism. One of the nice things is that even if that were to happen, none of your NFT links would break because it really doesn't matter who is providing the persistence. It's that content identifier just needs to be somebody on IPFS has to have it. So if NFT.storage goes away, you can still sort of keep that promise to whoever bought your NFT. So yeah. Oh yeah, if you want to do custom metadata, I think NFT.storage is still probably your best bet. So this Mark in the chat is alluding to another secret project called Web3.storage, which I'll have more to say about tomorrow. But yeah, I think that you would still want to use NFT.storage because there is, in addition to the store method, you can just store blobs of data through it. So you're not pressed into that standard metadata. You can do it yourself if you really have strong opinions about it. We just wanted to have a nice default for people to use to kind of ease the process there. But yeah, so thoughts on storing URI data to be accessed at minting time. If you're talking about fetching data from a smart contract directly, there is a thing I can probably find a link to real quick about. So the question is the safe way to store URI data is to be accessed at minting time, 1,000 URI metadata, pre-made files, and an NFT is minted, fetches that. So I was reading a blog post recently from Chainlink about Audius and how they had, for a large token distribution, were fetching this sort of authorizations from IPFS as part of their smart contract function using an adapter that Chainlink wrote. So let me see if I can find that link and I'll drop it in the chat. But it's kind of interesting. I haven't personally tried that, so I don't know if it's awesome or not, but it was definitely a pretty interesting read. Let me see here. So there's that link in the chat. And if you're not in our Zoom chat, you could just Google Chainlink IPFS Audius, and you'll probably get there. Yeah, there's some other interesting things that with IPFS and NFTs, we've been talking a lot about static data because that's the majority of NFTs. But we're also working on stories for evolving NFTs over time, but we haven't fully written that out yet. So that's something to kind of stay tuned to at NFT School, which is probably where we're trying to put some of those opinions in the future. Yeah. All right. I think We might be running close to time here. Does anybody have any last questions before I bid you all farewell? All right. Well, this has been super fun. If you guys want to get a hold of me personally, I am Yusef at protocol.ai. That's probably the direct route. And I'll be around at HackFS at least one more time for another talk, and I'll be around. I'm on tend to be on IPFS Discord and Filecoin Slack and things like
that. Awesome. Thanks so much for the chat.
Totally.
And yeah, if anybody has any other questions, of course, yeah, like Yusef mentioned, there's the IPFS Discord. There's of course the HackFS Discord, where there's a Protocol Labs channel or IPFS channel there as well. So if you have any last questions or any questions that come up as you explore NFT.storage and other kind of related products, those will be the places to ask.
It's not just me, there'll be a bunch of labbers hanging around on various Discords. So feel free to grab one and grill them about IPFS. On my attention.
Awesome. All right. Thanks so much. And thanks everybody for attending. And hope to